For weeks, the scientific world has held its breath, waiting, watching, wondering when China would finally release the image. Because while NASA, ESA, and every major Western observatory struggled with the blinding geometry of the sun and observational delays, one spacecraft had the perfect vantage point. One machine stood above the noise, above the uncertainty, above the excuses, orbiting Mars in complete silence, armed with instruments built for clarity, not politics. And that machine was Tianwen-1. Tonight the silence has broken. China has just released the first real image of interstellar object, 3I/Atlas captured from Mars orbit, taken during the period when every telescope on Earth was limited and NASA couldn't deliver the full picture. This image, combined with Tianwen-1's ultraviolet and dust monitoring instruments, reveals a side of 3I/Atlas we were never meant to see. A side that contradicts every prediction, defies every comet model, and leaves NASA unable to explain what it is. These new images don't just fill the gap, they expose it. They show an object behaving in ways that are not only unexpected, but impossible. And now, with China's release, the world must confront a terrifying truth. 3I/Atlas may not be what we think it is, and NASA can't explain what it is. This is the story of the Mars image that will force humanity to rethink everything we thought we understood about interstellar visitors. The document begins with the most important detail of all: geometry. At the moment, Earth-based observatories had limited access to 3I/Atlas. Tianwen-1 was in a perfectly aligned orbital segment that gave it a clean, unobstructed line of sight across interplanetary space. No sunlight interference, no atmospheric scattering, no horizon obstruction. Just a clear, silent viewpoint above the Martian sky. While NASA's observations were constrained, China's spacecraft continued monitoring without interruption. The spacecraft's high-altitude orbit allowed it to observe 3I/Atlas as it moved through the critical period around perihelion and outbound. The period when comets show their true nature: fragmentation, tail morphology, energy output, and sublimation patterns. But what Tianwen-1 recorded wasn't the violent fragmentation expected by Western models. It wasn't the disorganized breakup predicted by thermal stress. Instead, it saw a structure: stable, bright, accelerating with sustained activity. And as the document repeats, while Western telescopes saw partial, Tianwen-1 saw everything. The entire mystery of 3I/Atlas turns on that simple fact. The first released image from Tianwen-1 is not dramatic at first glance. A faint point with a slightly elongated envelope around the 5.6-kilometer nucleus. But to scientists who understand what they're seeing, it's a revelation. It shows a massive dust coma, not thinning or scattering, but thickening, stabilizing, forming a symmetrical plume around the object. Every visible wavelength analysis from the Mars orbiter confirmed. A dense cometary coma rich in water and organics, a sunward-facing jet structure, a tail that is already measurable from Mars orbit, a brightness significantly higher than expected and continuing outbound. But the real shock is this: the coma's brightness fluctuated in a periodic rhythm. Not random, not chaotic. A pattern. And patterns in interstellar objects are never ignored. Tianwen-1's ultraviolet sensors recorded a spike in UV reflectivity that corresponded perfectly with rotational models, except the amplitude was too high for a small, native nucleus. Something was either spinning faster than predicted or reacting faster than physics allows. This was not a quiet comet. This was an active engine of energy, and China had the only camera pointed at it. As 3I/Atlas moved closer to the Sun and then began its exit, European ground stations faced full challenges from geometry. The solar elongation angle made direct high-res imaging difficult. Earth was limited in angle, and any attempt drowned in constraints. But orbiting Mars, Tianwen-1 had the one vantage point that avoided the obstructions. The document emphasizes a chilling phrase. Mars was the only eye left open for the first real image. With every other observatory constrained, Tianwen-1 captured the development of new jet structures in real time. It recorded the elongation of the comet's dust tail and the formation of the antitail, a stunning plume stretching millions of kilometers. The antitail grew faster than early models predicted, far faster. This wasn't simple outgassing. This was directed release, forming coherent lines rather than chaotic spray, even as it sprayed huge amounts of water and organics. The document's authors note, if a comet behaves like this near the Sun and beyond, fragmentation must follow, but fragmentation was nowhere to be seen. This is the moment Earth lost control of the narrative, and Mars became the only witness that delivered the breakthrough. The photometry from Tianwen-1 shows something astronomers immediately recognized as impossible: a brightness increase of 0.3 magnitudes, with no visible structural breakup during phases when fragmentation is mandatory under classical models. Yet the nucleus appears coherent and the coma consistent. This is the paradox that the document describes in nearly every section. 3I/Atlas shows the energy profile of a shattered comet, but the structural profile of an intact one. And this is why Tianwen-1's image matters. It reveals the first contradiction in the laws of cometary physics. An object cannot produce jets at this magnitude without exposing surface area that no single body of its size possesses. Unless the object is hollow, or it has internal chambers, or it has a layered structure, or it is not a comet at all. This is the moment when every scientist reading the file realizes why NASA can't explain what it is, because this is the kind of data that doesn't just generate controversy, it generates fear. Every instrument on board Tianwen-1 agreed on one thing: there is structure inside the coma. Not dust, not noise, not artifacts. Structure. The document describes a dark ridge within the light envelope, a region of suppressed reflectivity that should not exist if the nucleus were spherical or irregular. It is shaped, distinct, repeating across exposures. The authors note its axial alignment relative to the jet and speculate whether this is a density fold, a thermal shadow, or a geometric occlusion. One possibility is avoided by all traditional astronomers except one: Avi Loeb. And now Tianwen-1 has produced the first image that supports his most controversial point: the possibility that the nucleus of 3I/Atlas is not random rock, but structured mass. If there is one detail in the entire document that stands above the rest, it is this. Tianwen-1 detected a sudden brightening and activity from regions where solar input is minimal. Comets brighten on the sunward side. They sublimate under heat. They eject material facing the star. But Tianwen-1 recorded sustained activity outbound. Emissions from the cold side, as though something inside it activated, pulsed, or released energy in response to the solar passage on the opposite hemisphere. The object behaved like something with internal mechanisms, not like melting ice. This is the brightest red flag in the entire dataset, and it came from Mars, leaving NASA unable to explain the persistence. Once China released the image, every Western agency immediately began reconstructing and analyzing the missing details. But there is a note of quiet resignation in the responses, a sense that the monopoly on astrometric truth has shifted. For decades, our planet was the observer, the vantage point, the authority. But now, a probe orbiting another world has taken the lead with the first real image. The scientists reviewing Tianwen-1's data acknowledge the jet structures match no Western models. The brightness evolution changes the orbital solution. The lack of fragmentation contradicts acceleration readings. The dust-tail geometry is incompatible with a single coherent nucleus. The object must either be in fragments, hollow, or operating under unknown physics. No one wants to write the last line plainly, but Tianwen-1 forced them to. The interstellar object is not behaving like a comet. It is behaving like something that adapts, and NASA can't explain what it is. The final act of the document is philosophical, almost somber. It reflects on the fact that we are observing an object older than our sun using machines that are barely older than our grandparents. It emphasizes the poetic irony that the first interplanetary mission of a rising space superpower has captured something that may rewrite the story of interstellar travel. The concluding thought is haunting. We expected dust. We expected ice. We did not expect sustained intention. And that line resonates because Tianwen-1 has given the world something no observatory on Earth could provide. A glimpse of 3I/Atlas from above the noise, from beyond the sun, from another planet. The images don't solve the mystery. They deepen it. Because now, for the first time, we are forced to confront the possibility that the greatest interstellar discovery in human history was never fully captured from Earth's sky. It was in Mars. In the end, the most haunting part of this story isn't the brightening or the sunward jets or the impossible antitail slicing across millions of kilometers of space. It isn't the dark ridge hidden inside the coma or the photometric inversion that made scientists whisper behind closed doors, or even the fact that 3I/Atlas behaved like something responding instead of fading. No, the most haunting part is that NASA and Earth observatories couldn't deliver the first real image or fully explain it. For the first time in modern astronomy, humanity's home planet was not the sole witness to its own cosmic history. Instead, the only eyes that remained open, the only camera that kept watching while constraints limited the rest, belonged to a machine orbiting a different world entirely. A machine built by a nation that refused to blink when everyone else faced delays. Tianwen-1 became humanity's only window into the full truth. And that truth is now impossible to ignore, because the image it returns doesn't tell a comfortable story. It doesn't show a peaceful, predictable comet following familiar rules. It doesn't give us the reassurance that what we're seeing is just another interstellar rock passing through our neighborhood before vanishing forever. Instead, it shows an object shifting, pulsing, brightening unexpectedly, releasing jets in coherent ways, forming structure where randomness should reign, refusing to fragment when every model says it should, gathering and sustaining energy where no comet can. As though the thing drifting through our solar system is not a relic of cosmic chaos, but a relic of something else, something organized, something built, something ancient. And the silence behind the release, the empty space between each sentence of China's document, speaks louder than the data itself. There is no declaration, no theory, no sweeping conclusion. Only the raw numbers, the strange image, the impossible behavior left hanging in the air like a question humanity is finally brave enough to ask. What exactly did Mars see? And why did 3I/Atlas behave differently when only one unblinking eye was watching? That is the question that now weighs on scientists across the world, with NASA unable to provide the answers. Not whether it is alien or artificial or engineered, but whether it is natural at all. Whether the laws of cometary physics, the rules we've trusted for centuries, were never meant to explain something that did not come from a comet-forming environment, did not evolve through the slow violence of star systems, did not carry the signature of randomness, but the signature of intention. Because intention is the one force in the universe that cannot be faked. And Tianwen, one's image leaves us with the uncomfortable possibility that intention might be precisely what we are witnessing. So now the world waits. Not for another theory, not for another press release, but for the next data drop, the next image, the next anomaly that will either deepen the mystery or finally tear the veil from whatever 3I/Atlas truly is. Because if these Mars images taught us anything, it's this. Our greatest discoveries may no longer come from Earth alone. And the next revelation might not wait until we're ready. If this story left you questioning what Tianwen-1 really captured near Mars, and why NASA can't explain what it is, don't let that curiosity fade. Subscribe to the channel because the next images could change everything we think we know about interstellar visitors. Turn on notifications. The moment the next observation drops, you'll want to be the first to see it. And tell us in the comments, do you think 3I/Atlas is a natural comet? Or did Mars just witness the first interstellar anomaly ever seen by human eyes that defies all explanation?